Did you guys get the name of the boat? It was C Sharp. Did you guys get that? C Sharp? Okay, maybe I should rename it Beam. Maybe I should rename it Beam, I guess. I don't know. We'll see how this talk goes, I guess. So I'm Keith Elder. You may detect a really cool accent. I am from the South, but I work in Detroit at Quicken Loans. We're based out of Detroit. I've been there over 15 years. We are the #1 largest mortgage lender in the nation. I know we have different people from different parts of the world here, so it's cool. In the United States, what you do is you go to work, and then you get your paycheck, and then you give it mostly to us for the house that you stay in. That's kind of how that works, right? So we're really good at closing loans and really good at mortgages. We actually are so good we have to slow the process down because we can close so fast that people get nervous. Did I make the right decision? Is it the right house for me? Which is a pretty cool place to be in. Today I wanted to give you a story about how we built this really highly scalable service that survived the Super Bowl. So it's just a story. I want to tell you like how we got started, how we found it, how we discovered the beautiful thing called Erlang, how we used it, how it did, and I'll give you all these different stories and stuff around it, okay? So this is basically what we're gonna do. I'm gonna give you some stories, and I'm gonna show you some live code demos, because I wanna show you the ones that twisted my head. I was an 8-time Microsoft MVP. I was considered somewhat of an expert in the C# .NET ecosystem, and so this is what I was doing before I discovered Erlang. And these demos are the ones I'm going to show you are the ones that I went, holy cow, how does that work? And so I want to share those with you today. And if you ever come across an object-oriented programmer, show them these because it'll twist their brain up. They won't know how it's done, okay? So I'm going to do that, and I'll tell you about some technologies and how we did it, how we used, and some lessons that we learned. You guys ready? Ready to go? Good deal. Let's go. So February 7th, 2016, where were you at? I was at home, a nervous wreck, because we were about to launch a Super Bowl commercial to 110 million people. And I chose the language Erlang to carry the largest load of our entire stack. And we had never deployed Erlang in production ever in our company. So basically, this was my time to shine or get fired. That's the way I look at it, right? And so this story starts, how many of you have actually heard of Quicken Loans if you live in the United States? Okay, so our marketing department's doing a great job. That's awesome. A lot of hands going up. You saw the commercials, right? The product that we were launching for that Super Bowl is called Rocket Mortgage. Rocket Mortgage is an app. It started in 2011 whenever Apple announced the iPhone 4S. The iPhone 4S had Siri built into it. And it was kind of this aha moment for us. We went, that's pretty cool. And we should probably do something with that later on. We saw that our clients wanted to do mortgages wherever they were at, right? And they had this device with them at all times now. Really, cell phones were getting popular, right? And so we said, like, this is something that we really need to do. And so Rocket Mortgage, if you're not familiar with it, you can go to rocketmortgage.com and you can fill out and get a mortgage application approved in under 8 minutes. Done. We verify credit, we pull credit, we verify your income, your employment, your assets, everything about you. We can pretty much automate that. Now, if you're a consultant, you work for yourself, you're out of luck, you got to call somebody on the phone, right? We can't do that today. We can't verify your stuff if you're self-employed. But if you work for, some of the major companies in the world or in the States, we can verify that stuff. There are ways to do that. So that's what Rocket Mortgage is. It's an app that we basically process mortgages with. This story starts, though, back years before the Super Bowl. So in 2011, we put a team together, about 50 or 60 people, sent them off to one of our buildings in downtown Detroit, built out this really cool space for them, and said, we want you guys to rethink the mortgage industry. Challenge everything, right? Don't use any way that it happened today. Think differently about it. And so we sent this team off over there, and they started building it. Well, things started, working and getting better and better, and eventually they got to a point to where they could actually, do refinances in the state of Georgia. Why did we pick Georgia? Easy laws to deal with. We kind of picked it. So if somebody would go to quickenloans.com, they would actually see Rocket Mortgage. We didn't tell anybody, but it was there. But so they built a commercial, a fake commercial, a fake Super Bowl commercial, and they played it in front of our chairman and our CEO and all of our execs. And they played the commercial as to what would be if we launched the Super Bowl, if we launched Rocket Mortgage at the Super Bowl. They were trying to get all of the other states done and go faster, right? That commercial churned the entire executive team around, and the next day we started and we were 1,000 of us in technology. They cut technology in half and took 500 team members and said, stop what you're doing. You're not going to go work on this. And we started for the next 2 years. And we had to march to that February 7th date, right? And that's how we got started with Rocket Mortgage, okay? So we're working, we're doing things. Every Monday at Quicken Loans is innovation time. So every Monday at 12 o'clock, whatever you're doing, you go to lunch, you come back, you can sit at your desk, you can read stuff, you can hack on whatever you want, you can learn different things until the end of the day Monday. That's every Monday, right? Unless it's a holiday. We're actually changing that to, we're doing a full hack week. So after everybody does their quarterly planning and does that stuff, at the end of that, everybody has a hack week and hack on anything you want for the entire week. Then there's a big show where everybody gets on stage and shows what they did, and then the winner gets to go on and work on that for an extra quarter for whatever project that they did. So we have a lot of innovation stuff going on here at Quicken Loans. We are essentially a technology company that happens to do mortgages. That's a really good way to think about us, okay? So it started here. So Mondays, this is kind of how it started. How many of you have built websites like this? You have a database and you have a web server. Come on, we all have, right? So I call this the blog architecture. It's like the famous WordPress blog site, right? You got a database, you got a web server, you put some stuff in it, right? If your blog gets popular, well, you need to add some caching to it. So this is the popular blog architecture of it, right? And then if you really want to get crazy, it's like, man, my blog is really popular. I'm going to add a web farm, some load balancers, some cache clusters. I'm going to cluster my database. Sweet, this thing is rocking. And this is the enterprise blog architecture. Okay, this is how we built apps, right? Java, .NET, a lot of other different apps are built in this way as you scale and as you go, right? This is very common. But then you kind of get into this other thing where you realize that you really need to do like event-driven type of stuff. So you need pub/sub, you need messages. It's kind of a big deal because you need to offload processing. It's not always synchronous. It needs to be asynchronous. And so I call this like a queued services architecture. You could call it like an event-driven architecture, right? If you guys follow me? All right, and so we were building this, and so this is complicated. It's complicated because you have, in the .NET space that I was in, you would deploy Windows services to handle all the pub/sub and all the asynchronous processing. And you would have APIs that were deployed. And you would have a web service stuff that was deployed. It was a composite application made up of multiple deployments to build one thing. If something went wrong with it, holy cow, figuring out what happened. So it was all about logging and putting stuff in. It was complicated to deploy, it was complicated to manage, and if something broke, it was crazy. And so we had built out this stuff very, very highly scaled. We knew how to do this really well when I was the director of software engineering there. But one day we said, man, if we could really figure out the messaging part of things, this would be cool. It's really about messaging at the end of the day and how you do messaging, right? And so we sat down and we said, let's take all of the stuff in red here. Let's take all of that and let's rethink it. Let's just throw it out. What if we got rid of .NET right now? We're not going to use C#. Let's go, what would we do if we did it differently? Let's just rethink. Let's take our innovation time and really push the envelope of what we're going to do, okay? And so we grabbed this book, 7 Languages in 7 Weeks. You guys heard of this book? Okay. I think Erlang is number 4 in the book. In here. So you got Scala and Haskell and IO and all those different things and Ruby. And so we started going through this during innovation time, right? And playing with different languages and stacks and kind of seeing like, well, could we go faster? Could it do this? Whatever. And then we all kind of got to Erlang on the team. And we all kind of stopped. And we're like, did you read that page so-and-so in the book? Like, yeah. Did you read what it said? Like, yeah. How does it work that way? I don't know. Okay, well, let's go figure that out. And so we started playing. And this went on for like a year and a half. And we kept playing with Erlang during innovation time every Monday, right? Kept playing with it. Because we kept finding out like, oh, that's cool, it does this. Oh, that's different. That's neat, right? And so I found this like tweet one day. And I was like, okay, I found this tweet. And I'm like, okay, it's a battle hardened. Okay, it's been around a long time. I remember seeing the books in Barnes & Noble when I used to walk in the bookstores a long time ago. I remember seeing the Erlang book on the shelf a long time. I didn't ever buy it. Okay, battle hardened. X platform. Okay, it runs on Mac, Windows, Linux. Okay, that's cool. I'm down with that. That's awesome. Functional language. I like functions. That's cool. I usually put them around classes, but I can leave that off. That's okay, Makes writing reliable, concurrent, distributed systems of joy. Like now they're full of, you know what, there's no way that that's going to be the case. I don't know, somebody's smoking something. We're in San Francisco and it's legal, so it's fine. Reliable, concurrent, distributed. Reliable. I like reliability. I need reliability in my applications. Concurrency means I can handle more load and do things, and distributed means that I don't know what that means yet because I'm a .NET developer and we don't distribute things. So I need to do now more research into what I'm doing. So here we go. So I said, okay, well, where's Erlang used? And I started finding stuff, automotive, drones. I saw this YouTube video, this drone flying, and the gentleman put a bug in it, and so the drone was sitting there and it was doing this. And then he deployed in real time while the drone was flying, and the drone stabilized. And I went, oh, Lord, how did he do that? That is amazing. That is crazy. Because in .NET, you'd have to reset the application pool, and the whole drone would have went and hit the ground, and you'd have to fix it and then restart it. Right? That is really cool. And so I'm like, gaming, what's up with the games? Who's using that for games? And why? What's the deal? Oh, concurrency, because gamers don't want their games to disconnect whenever live updates are done at 2 o'clock in the morning. I get it, massively multiplayer games. And so I found this company that's in Europe, and they do that back-end stuff for all these games. And I was like, that's very interesting. They actually rewrote their stuff in Erlang they had benchmarks. I found these benchmarks of C and Python that they were doing, and they said, well, Erlang. And I was like, that's really interesting. Okay, this is important for a director because as a director, if I say, hey, we need to use this thing, what do I have to do? I've got to have all the answers to the thing, right? How we're going to support it, what does it use? Give me some examples, so on and so forth, right? So then I found this, because I actually knew this. In .NET, for example, if you start a thread, okay, it takes up 1 megabyte of memory. And I didn't get the whole concurrency thing with Erlang starting out. But I found this, and it said, oh, well, process in Erlang takes up 1 kilobyte. Is that still the same? I think it is, right? One kilobyte? I'm like, oh, OK, so if I have 10,000 customers hit my server, how much memory do I need to handle 10,000 processes in my application and all that? It gets really different, right? So I was like, that's crazy. OK, I don't understand it. But I'm reading, I'm researching. Then I found this whole distributed thing. All of the nodes talk to all of the other nodes, right? You got another node, they're all friends. I'm like, I can't do that in .NET. I don't know how to do that. Like, that's kind of breaking my brain right now. I don't know how this works. And so I want to show you a couple of these demos that I saw. Finally, I found some of these demos. I want to show you a couple, okay? Is that cool? And honestly, if you have friends that are still object-oriented programmers, just show them this and say, now you do it in 2 minutes. And let's see how the brain hurts. So hopefully this will work. It normally has in the past, but it's a live coding demo thing. So, all right, so the first thing is, I'm not going to do hello world, any of that kind of stuff. I'm just going to start the Erlang VM. I have this little thing here called cheat process. And what it does, all it does, I want to compile it. What cheat process does is it takes, and you give it a number, it's an arity of 1, you give it a number, and then it will calculate how long it took to spawn a process. It does nothing, okay? I just want it like a benchmark kind of thing. So cheat process start, and there's also end time. So if I give it like, create me one process, it's so fast you can't even really calculate it, right? So let's give it a little bit of fun. Let's give it 10,000. So create me 10,000 processes, right? So my thinking is like, oh, Super Bowl commercial, 10,000 people hit our website, boom, 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 boom. I've got, okay, well, that's pretty interesting. So it took 1 millisecond to create 10,000. And of course, I had to like press the envelope here and keep going. I'm like, oh, okay, now they do 1 million. And so if I get up to like 1 million, normally it runs in under 0.90 seconds. I spawned and created 1 million processes, which are not operating system processes, as we all know on the beam, but still, that was like, okay, now I've got an example of what it was for the .NET thing versus the Erlang thing. This is, okay, I'm starting to understand the concurrency thing about Erlang. You follow me now? So I'm like, this is cool. I want to show all of my coworkers, like, did you check this out? Watch this. And their minds are getting blown, right? So, distributed. I was like, I don't know how this thing works. So, I finally found this example. You guys remember the Flintstones? Most of us in here are a little bit older. The Flintstones, you had Barney and Wilma and Dino and all that. So I have an example here. So this Bam Bam shell script, you notice it just localhost sets a cookie Dino. So we're going to create I'm going to simulate 3 Erlang nodes, and I'm going to connect them together. Okay? So I'm going to start bam, bam here. We'll do old Fred over here. Okay? And then we can start Betty down here. So I'm basically simulating here with 3 different nodes on the screen. They're all connected with that same cookie, right? And if I come over here to Fred, and I'm like, hey, Fred, how many nodes do you have? Right? I don't have anything. Okay, but they're all sharing the same cookie. So I'm like, okay, now, how many lines of code do I have to write to connect them? And then I found this thing that says, like, oh, you just do net_ADM, you do ping, and then you give it the name of the other node. I'm like, okay, this is kind of cool. Let me do that. And I got back Pong. And so I was like, I am so winning right now. Like, oh, Fred knows about Betty. This is cool. Then I'm like, what happens if I go to Bam Bam and tell Bam Bam to add Fred? Will Fred know about Betty? That's like the ultimate test, right? I was going through this in my mind. So I'm like, okay, let's go do that. And so I went over net ADM. And I did ping. And I said, okay, let's add old Fred back. Because we didn't add him earlier, 1001. Did I type all that right, guys? Help me out. And then I type nodes. I'm like, oh, he knows about Betty. This is so cool. They're all, boo, pow. I'm like, oh, man, come here and look at this. Check this out. Look what I just did. And he's like, well, how much code was that? I'm like, it was just like 1 line. I just did this cookie thing, and it was so cool. Every demo was like, it was 1 line, right? That's the best code demos, right? I'm like, this is pretty neat. So I said, okay, I read about this whole, you can do code and updates. You can apply updates. And I'm like, okay. So I wrote this, or I stole or copied, I can't remember, but I attained it some way, internet. I have this little program here called Blabber. And so Blabber is a program that I can just say, I want you to start talking. Just print something to the console every 2 seconds. Okay, every 2 seconds, but I want to do the whole loop. So I'm saying create a loop, create a number, and every time you print, increment, right? Okay, so this is what Blabber does. And all I got to do is just start it, okay? I'm like, okay. So, I mean, it was like a moment whenever I ran this. Of course, you know, give a little love to Detroit, right? This is where I last ran this demo. So what's up, Detroit? So I'm like, cool. And I'm like, okay. It works on Bam Bam. These dudes are all connected. Can I do this? If I go over here to Fred, by the way, and type blah and hit tab, there's nothing there, right? But if I say network load, and then I come back, I've got Blabber over here on this dude. Oh, Lord, that's amazing. So I'm going to start it. Does Betty know about it too? Oh, Lord, she knows about it too. This is getting really cool. Look at my demo. This is awesome. Got his stuff. I'm like, now. I read I could do dynamic updates with Erlang, though. I could, like, put stuff in. I had to start. So how would I do that? So I was like, OK, so let me go to Blabber, Erlang. OK, let's do that. And my Vim is a little broke right now. It's OK. So if I go to Detroit, let's whack that out. We're at code of the beam, right? So I'm going to write that dude out. Come back over here to Bam Bam. And so let's just, hey, Bam Bam, I need you to recompile this thing, right, for me. Dot. And so what happens is you'll notice a little bit of a hiccup, and boom, picks up. I'm like, oh, messaging is awesome. This is so cool. I get it now. It's a message. It's an inbox. It put the thing in there. I restarted it. It figured it out, did the stuff in the background, and it's there. Then I'm like, could I deploy this change to all the other nodes now? Can I? Can I? Let's do this. So I'm like, okay, watch the other ones. I was like, is this going to work? Is this going to work? Oh, my goodness. It had me. I was hooked. I'm like, how in the world is this doing this? Okay. Now, I've done this demo before, closed my laptop, went on a plane, left my MacBook Pro at home, and came back to work Monday morning, and it was still running. So it will stay. It's very reliable as well. So I was like, those are the demos that I saw. And if you saw how simple they are, you can replicate those for some of your stuff. Again, my code is on GitHub. Again, at Keith Elder Presentations, Why Erlang, go grab the code in there. You can share it with your friends, okay? And so I was like, all right, here's what we've got on the team. I was like, well, we need things that can't fail. This thing is distributed. It's very fault tolerant. You just let things fail and let things work and let errors handle. And you can do upgrades while the app is running. Can't do that in .NET. You got to stop the server, reload the code, pull it out of the thing. You know how it kind of works with all that stuff, right? hot swapping. You don't have to stop the system, and this large number of concurrent. I just created 1 million processes in under a second. Like, that is nuts to me. Okay, cool, sweet, winning. Now we have a solution, but we don't have a problem, right? Because we're still writing .NET every day. We're doing our thing and doing other stuff and, fighting all that kind of stuff. So we had this, we were, like a year and a half in, and we're like, this is cool. And we were, of course, sharing it with other team members, what we had found out. And they're like, yeah, that's cool, but I don't like the syntax. I'm like, well, it still functions. You're just typing less code. And they're like, I don't like it. I'm like, okay, whatever. So the Super Bowl was 302 days away, okay? We've been playing with Erlang for year and a half. We actually sent some team members here in San Francisco back a few years ago, and they came. They were .NET developers when they arrived, and they were Erlang developers when they left. So you guys did a great job of getting in their heads. The Super Bowl was 302 days away, and one of the architects walks up to me, and he says, "Hey, you remember?" I'm going to speak in generic terms because it's because I can't tell you exactly what happened. But he says, "Hey, you remember the thing that we were going to do to handle encryption in the cloud?" I'm like, "Yeah." He said, "Yeah, it's not going to work. We don't have an answer. We can't do it. It's 302 days away as a Super Bowl." And he says, "Haven't you guys been playing with Erlang?" I said, "Yeah, we've been playing with it." He goes, "Do you think it could handle these requirements?" That he handed me a piece of paper. And I said, "Well, I don't know." He said, "Oh, by the way, you only have 90 days to build this thing." And remember, we've never built an Erlang thing ever. These were senior .NET engineers, right, on the team. He says, "You have 90 days because you've got to get this figured out and deployed way before the Super Bowl so all the other teams can get their stuff done and pushed and tested and performance and all that stuff." And he said, "Here's the list. First of all, our chairman, Dan Gilbert, who I absolutely love, is a great, great man. He's a billionaire, but even though with all of his money, he cannot move the Super Bowl. It's a hard date." Right? And so engineers, we don't like hard deadlines, right? But it's a hard deadline. It's going to happen February 7th, 2016, regardless. He said it needs to have we want a 1 millisecond response time on this API. That's what we need. And it needs to do 30,000 transactions a second. I know how many .NET will do a second, and I know how many servers that will cost, right, to actually perform that. He said, "Oh, yeah, it's got to be always on." I'm like, "Oh, this is sounding good." Whatever the service does, it needs to support all these languages. Oh, it needs to be a hybrid cloud out, so we need it on premises and in the cloud. I'm like, okay, this is getting tough. And I want to make it easy for developers and easy for REST and all that. He goes, "Can you guys do it?" So we said, we have no idea, but we're up for the challenge. This team that I was leading was like an elite ninja force of senior developers. They loved challenges and hard things. And stuff that we built was really, really tough and hard at scale. So one of our architects said, "Here's the API we need." He gave us the REST API that we needed. And he said, "Come back." He said, "You guys start Monday." They told me this on a Friday, by the way. So you look at this graph. This is from our GitHub Enterprise internal thing. You see a little spike, and then it kind of dips down. That first little section is where we wrote a proof of concept. Right? So the guys we all went kind of nuts and for a couple of weeks and wrote this proof of concept to see if it was actually could do what we said it would do. The other large spike that's in here is we did find out that it was going to work. Obviously, I wouldn't be up here telling this story, but that was the amount of work that they did, and then the tail off is a little bit of a hump where we did some refactoring, right? And then deployment. So that was what we did. Now, this was 2,000 lines of code is what we wrote. I'll show you how it works and what we built in a second. But it was 2,000 lines of code. It was 2 senior engineers that wrote it, their first Erlang app ever, right, in production. And it's the most used service in Rocket Mortgage. It literally is. It's every time somebody clicks a button, it kicks off all, because kind of, being a financial company, encryption is kind of important. You guys agree with that? It's kind of important. So yeah, we take that stuff really seriously. So here's the stack that we used. Now, we had never built any of this stuff before. We had never used it, but we kind of figured it out. So the thing that we used, obviously we used Erlang. We used LevelDB for local storage of all the keys that manage the encryption stuff. We used React Ensemble to take all the keys and distribute that across all the nodes, to keep all the data in sync across everything. Cowboy was the web server. libsodium was the libraries, open source, that we used to handle all of the encryption. That gave us access so that the C# guys or Java or PHP or any other language you can think of could encrypt and decrypt data with the same type of library. And then Exometer gave us like insights as to how the thing was running, making sure the lights were on, right? So that's a stack that we chose. And then we had this moment of truth. So we did the POC, right? We did the POC, and we deployed it out to this little dev environment. Let me explain this little dev environment. This was like install CentOS 2 years ago. We put Erlang package on it. There was no configuration. It only had 1 gigabyte of RAM. It was a very simple, these were just dev virtual machines that we could just throw and sling stuff on, right? So there's no optimizations, no nothing, none of that stuff going on. And we ran a load test, and in 1 second, we got 12,881 transactions a second, which sounds pretty cool. And that sounded cool. I was like, well, we're not there, but I could add more servers, and I could get to my number. But what happened is, I learned that the tools were wrong. So they were using these Java tools to test the Erlang service. And he said, your service is broke. And he sent me a screenshot. I'm like, that's a Java stack trace. Your tool broke. This never flinched over here, right? And so I was like, this is as much as we could get them to stress this thing. And we got 20,000 transactions a second with it. And I'll talk a little bit more about that here in a bit. So we knew that we put regular hardware, we did some tweaks and put the latest stuff on it, and we did a 5-node cluster. We're totally going to be totally fine for whatever we wanted, performance-wise. So we said, okay, let's go ahead and do the work. But here's how the thing works. So you take application A, says, hey, I've got some PIFI data, and I want to send it over to application B. So it goes over to the service and says, hey, I need to send something to B. It says, cool, here's a key, right? It sends it over to B. B's like, cool, I'm going to process it now. It goes back to the service and says, hey, I need a key for applications A data. And it says, cool, here's a key. So you can imagine, as things go through a pipeline, how many requests are coming to this one service. You guys follow me? It's literally just hit constantly all day long. It's crazy. So that's how it works. And I'm on a picture of the firewall. You guys get that? You're in the middle, firewall. You got it? Okay, we're all the way. So it's a hybrid on-premises system. So there's 5 nodes on premises, and then there's 5 nodes out in the cloud. And so the way that it works is we have an interface, administrative console panel, whatever, it's a web thing, and we put a key onto a node, right? We just say, hey, I need a new key. When that key gets added, React Ensemble then takes over and sends all of that key and syncs everything up across all the different nodes on premises and in the cloud. And that happens in like milliseconds. It's like less than a second. Doesn't matter. So those keys are now out there. They're also replicates. Now we have 10 copies of our keys, which are very important for financial data. We can't lose those. But also we have backups and stuff like that. So that's how it basically works. And the reason you're like, why do you need cloud on premise? Because we start in the cloud, but then we have our own data centers, but we move that data back on premises with all of our internal systems that do stuff, and things get pushed back and forth. So encrypting and decrypting on premises and in the cloud was a solution that we had to have. It was very important. Okay? And so then we go back and say, well, okay, how did we do at the end of days, right? So we had a hard deadline. We made that. We got it deployed in July, okay? The millisecond response time was dead on, like is literally a millisecond or even less for response times. We absolutely blew through the door on the 30 transactions a second. I'll talk about that in a minute. It's always been on. So we deployed that in July 2015. So in July of this year, it'll be 4 years that system is running. It's very important. If you can't encrypt or decrypt data, we can't do a mortgage. And that's very important for our business. You guys get that? kind of important. Batch array languages, libsodium gave us that. Hybrid cloud out, we figured that out with React Ensemble. That was great. Encryption at rest, the libsodium helped us with that. And then easy for developers. What you may not know is we actually open source at Quicken Loans a library called Rock Framework. We call it RockLib, actually, because RockLib wasn't available, but we got rockframework.org. And so it's out on GitHub. And so this is what all of our .NET engineers use to handle logging, all that DevOps or ILITY stuff that you need to do in applications that we all hate doing as engineers, but like logging, messaging, encryption, those things that are reused in every single app this library takes care of. Don't worry about the top part. The bottom part where it says public class foo, what you'll notice is there is an attribute on the property called Baz, and it says encrypt. And so in the config file of the app, there's some stuff there. The developers, if they're serializing or deserializing data with that encrypt attribute, it automatically is handled for them by the actual framework. You can use this if you want. You are more than welcome to write your own encryption service, but you can plug that into the framework and then use that. So if you want to encrypt the entire object graph of foo, you just drop the encrypt attribute on foo, and then the entire object graph below that will be encrypted. Okay? So you can't get any simpler from an, it's like the .NET engineers we brought them into a room and we said, hey, this is how we're going to handle encryption. And they're like, okay, let me get my notepad out. And I'm like, okay, you guys ready? They're like, yeah. I said, add this to your properties that need to be encrypted. Any questions? So pretty simple, right? So we checked that box off. Now we're back at February 7th, 2016. And I'm sitting in my house, and basically, the feeling I had at the time was this, right? I'm excited, but I'm scared. Like, this is the first time we'd ever put this thing into production. This is 110 million people tuned into a Super Bowl. This is 5 years of effort. We would do load tests in the cloud that we would buy Cadillacs with a load test, right? We spent a large amount of money. People are like, man, I can't believe you guys had a Super Bowl commercial. That was a penny compared to the other money we spent getting there, right? So I'm sitting there that day, and basically just waiting for stuff to happen. A little side story that actually happened was 2 hours before our Super Bowl commercial aired, all of our website went down, the whole thing. We had prepared, and we had all of the unit tests, performance tests, everything was ready. Here's the short story of it. What turned out is one of our operations guys changed the config file in Akamai, one little line, and it got deployed out to Akamai, and the website was just giving white pages. This is 2 hours before. So you can imagine, panic, right? And literally, we figured it out, and long story short, we got it done in time. We had 20 seconds left before the commercial aired, so no big deal. But literally, it was 20 seconds before the commercial aired, before it all went live and went hot. So it's a really interesting day for us, to say the least. But what did we learn after the end of days, right? Obviously, when we dropped Rocket Mortgage, the industry and fintech was completely caught off guard. They didn't never see this thing coming. We were like as secret as like an Apple release or something. We didn't tell anybody. We had vendors sign in blood. I'm kidding, but they were sworn to secrecy and all of that kind of stuff because we knew this was going to change the mortgage industry and change the fintech space, and so we kept it internal. But the things that we learned from this, the first one is, Beam is awesome. It's a very awesome platform to build stuff on, especially for highly performant APIs. I'm a firm believer. I'm bought in now. It's really, really been awesome to see it work. And by me seeing it work, I need some wood somewhere, that it's still working, 3.5 years later, that it still hasn't had any downtime with it. So very performant, very viable platform for those APIs. The next thing that we learned is, throughout the whole thing, is don't use Java to test your Erlang APIs, because you'll break the tools of Java. So you need to learn, if you're going to write Erlang, you got to test Erlang with Erlang. It's the only thing that can spin up enough concurrency and put enough load on your stuff. We have never actually benchmarked fully what our system will handle. We know that it is just extremely light and fast, but here's what we did learn, is that people used to call us and go, hey, we're going to load test our services over here tonight, so you guys keep an eye on your encryption service. We're like, okay. And they finally stopped calling us because it just worked all the time, right? So we don't. So every load test that got done ever that still gets done still load tests this, right? We even use this to put load tests on the gateway, and we found bugs with the gateway because this never broke, right? But so if you're going to test Erlang, you got to write Erlang code to actually really test it to figure out what your numbers are. We learned this is to keep all of the nodes independent. For our case, your case may be different. For the 1 millisecond hop, right? We didn't want to add another system dependency or point of failure, right? So we didn't want something to come into the node, and then it had to go reach over to a database, right, and come back. That was going to slow it down, okay? It would also give us another point of failure. So we kept everything local on the node, all the data, all the stuff. So if we want to just add another one, we could just spin one up, throw the stuff on it. When it comes into the cluster, React Ensemble went, oh, I got a new buddy. Here's some data. Syncs all the data over to it. Once it all gets synced, then it's ready for rock and roll, right? And so that was something else that we learned with it. We also learned this, that when you have senior .NET engineers, they can just change one thing and really kill your performance because they don't really understand what OTP is doing under the covers at some time, which is okay. So what we learned is every time we would push something to dev, we would do another load test, right? Every single release, we test it every time because any little micro changes that we would make would sometimes have significant performance impacts on it. I mean, one time we did a load test, and guess what we found? Somebody left like verbose logging on. We were like, man, it's slow. Wow, look at all the logs it generated, you know? So you find stuff like that. So we always did performance testing of every release of it. That's something that, because we were very focused on the performance side of that. And the question everybody asks is like, would you do it again? And my response is, has anything been invented since then that's any better? And I can't find it. I mean, Elixir is out there. So I'd say, yeah, probably you may look at Elixir instead of Erlang. I don't know, going back in time. But there's nothing since then that does what this do. You guys just saw the demos, right? It's pretty impressive as to what the platform that we have here. And so we'd absolutely do it again. I got to keep my job, so that's awesome. I did get offered a trip to Cancun for all of my work. I appreciate my employer, but I went fishing on C# instead, which is kind of ironic, I guess. But the really great thing about this story overall is this. This is what I tell everyone. Even if you work for yourself and you're self-employed or working for whatever, we wouldn't have had a solution. We wouldn't have figured out what to do with this in a 90-day window if we hadn't had innovation time. Think about that. This whole story hinges on us actually being able to innovate weekly. So what I tell every developer and engineer that I come across is like, look, go back and tell your bosses this story, your team leads, and ask for time to innovate. It is so absolutely important. You can ask us how we do it. We're happy to share if you want to get in that space. But even if you work for yourself, give yourself time to look at the future and what's out there and tinker and play. Right? It's just so important for all of us to basically do that. And so really the innovation is the circle of this, that we wouldn't have had who knows what we would have done. I have no idea. I really don't have another answer because the thing that we were going to do wasn't going to happen. And so thank you for our innovation time with that. I am basically done. I will be around. I'll answer questions from here. I'm going to fly back tonight, but after this, if you guys want to have any more conversations, I'll just walk to the lounge after this and I'll hang out. So I'll be glad to take any questions you guys have. Thank you. Yes?
So the requirement was 30,000 transactions a second. What did you get anywhere near? Did you actually get hit with anything near that, or was it a lot lower?
No, we definitely got hit. We actually got hit probably a little bit over that.
Really? Okay.
Yeah, when it actually went. It was like, I mean, you're sitting there. And so here's the thing about Super Bowl commercials, that you don't know when a commercial is going to air. So that whole story I told you about, 20 seconds left, that's the thing, is like you don't know. You buy a window, like, well, we're going to be the first spot at the start of the third quarter, right? So like if Al Michaels or whatever is doing the broadcast and he's talking longer, he may talk an extra 5 seconds or 10 seconds, well, it pushes your ad back, right? So you don't know when you're going to actually go, when your ad's going to go. And so we're literally, we had a whole mission control, and we were looking at everything. As soon as it aired, the commercial did, it just went. It went nuts. We also did another Super Bowl commercial. I think in 2017 we did another one. I think, and that was the one where we had one of the comedians come in, and it's just it's like everything's being simple, right? Just simplicity. And he comes in, and there's these two people in this art gallery, and they're staring at this like gray-looking circle, and they're sitting there like, and he walks behind them and goes, "It's a gray dot," right? So we're trying to simplify everything in terms of the mortgage space and that. So yeah, we hit those numbers, and so as soon as it aired, it just poof, right? The crazy thing is, what we learned is talking to a lot of other companies that do Super Bowl commercials, they fake it. And so they create these what they call skinny sites, all right? And we named ours internally Skinny B. So we had the A version here, but then we had the B version. And the B version was just throw something up, right, that handles the actual load. Some people may put a form on it and take some data and do whatever. But this was like, we're different. We were like, we're a tech company. We're going to do the full thing. You know, we're going to pull credit and validate employment. And literally, like after a few minutes, we got our first approval of a home loan. It was like crazy, like awesome, right? All this work coming in. Now we had already teased it out at other areas like Cyber Monday and other places, but we just didn't tell anybody, right? So we waited for that nationwide launch to really drop it out there. So yeah. Yes, David.
How did it drive Erlang adoption to the rest of the world?
Well, people thought it was really cool, right? But they're kind of stuck in some of their stuff over here. We also built some other infrastructure services with Erlang to handle all of our logging for all of our apps and all of our services coming to this one thing, this one Erlang system. So we reuse it there on our team. I went over one day and I was talking to one of my buddies. He used to intern for me a long time ago. And I went over to his house. He lives right across the street from downtown Detroit. And I went over there, and he's a PHP developer, right? So everybody says, like, we need to get more people on Erlang and Elixir. You know what I did? I showed him these demos in his apartment. And whenever I showed him, he was like, oh, wow, oh, crazy. He's now an Elixir convert. He is like crazy. And so if you go to quickenloans.com today, if a page loads really fast, it's Elixir. And if it loads really slow, it's PHP. All right, because it still hasn't been converted to the CMS. So it's out there and in there, but it's not like everywhere yet, right? But people can use it if they so choose, right tool for the right job, all that kind of stuff, right? Yeah. Question? Yes, sir.
Yeah, so I think I wish there were more directors who were like looking at Erlang for some of these new projects. It's amazing that you did that.
Yeah, I just heard here's what I heard. I'm awesome. Is that what I think I just heard that?
Once you deployed the app, did you see like a significant less amount of effort you needed to put in towards maintenance versus .NET, some of the other .NET apps that you deployed?
Yeah, I think it's like, the features that we put in were like a minimal viable product. We went back at, through different areas. Once we got the MVP out to give it to the developers, we had to coordinate with the frameworks and all that stuff, which our team wrote. And we went back and added some more APIs, some other stuff for like administration panels and things like that. But it really hasn't been a whole lot of anything with this. It's just been working, right? Because the business, it encrypts, it decrypts, they're happy. Right? It's fairly simple, but it's also complex at the end of days. With our .NET stuff, you're always like, Microsoft is awesome. They got a lot of employees, and I really respect Microsoft tremendously at what they're doing. They've also open sourced .NET today, so it's all completely open sourced, and they're running all across platforms as well now. So they've got some really good performance numbers today versus what they used to have. And what's interesting is like there's all of these different upgrades and things you have to do for .NET, and you got these different versions. It's more complex, I think. It's like you get, you have OTP 21, right? That's it. Put your stuff on it, rock and roll. Like it's a little more simpler, for that. Things don't move as fast as they do in the .NET space. But that's for stability, which is a good thing. So the big thing I've seen is the 2,000 lines of code. I don't know how many lines of code it would take to write that in C# or some other language, but I do know in the other stuff that we've written, that we've rewritten, it's 75% less code. than if you write it in C, C#. And that's because you're writing all this defensive programming. Try, catch, log, right? All of these defensive stuff, right? Is this value null? Is it not null? Do this. If it is, do that, right? All this defensive programming that you have to do, plus all the syntax stuff that's it goes along with curly braces and semicolons and all that stuff that can get kind of complex, right? So 75% less code is one thing I've definitely seen. And it may be 70%, 75. We're going to say 75 to make it sound cool. It's a good number, right? It's good. Yeah. I saw your hand first.
Is there anything you could talk about, like deploying updates, or particularly with upgrading versions of P, or updated dependencies, like SSL libraries, or things like that? Any problems, or?
We haven't had any problems. So the question is, can you talk about dependencies and upgrades and things like that? We haven't had any problems. As a director, I get to say that I don't have to do that, right? So my guys, not my guys, but our guys on the team are really awesome. They figured out that stuff. They went through a lot of stuff to figure out how we couldn't break it and trying to figure that out. I know they use rebar for that stuff. But it's really like, it's right now just sort of in, hey, we're keeping an eye on if this library thing had a security thing, then we got to go back and patch it and do those kinds of things. So it's kind of in maintenance mode at this point for the most part. But I really can't answer your question fully because I have forgotten part of that stuff too. Just being honest. Yes?
So talk about your innovation time and having experimented with Erlang. Going from the 7 languages book, what was your process to actually get up to speed to feel comfortable at the book?
What was the process to get up to speed to feel comfortable with Erlang?
Like toy apps or
Yeah.
books that you're reading?
Yeah, we read a lot of different books and stuff, but we just started taking problems that we had and like, how could we just replicate that over here? Because at the end of the day, when you take on a new language or a new stack, you really have to have the answers to the stack, right? How do you test it? We had to figure that out. How do you deploy it, to his question? We had to figure out the best way to do that. How do you make a release, right? Or do you not make a release, or you just copy the files? Like, we had to figure out all of that with our build systems, and there's a lot to figure out. And we knew we were going to get challenged with that as well, right? When we said, hey, we want to use this thing. The way that it worked for us is that the business had such a need, they were just looking for a solution to something, which was an awesome position for us to be in because we had that innovation time, right? For sure. Yeah. I think Todd, right? Nicholas, sorry, Nicholas.
Yes, I was going to ask a question. I noticed that you had React Ensemble with level DB. Actually, React actually has a level DB backend back in 2016, still does now, and also has multi-base interpretation. Why did you choose to have those as two separate things instead of using a package that already has them?
All right, so the question is, we had React, why didn't we use some of the other React backend stuff for that it had instead of level DB? Is the question?
Why did you have it separately rather than just putting it as...
I have no idea, is the answer. But I do know whenever the engineers were looking at it, it came down to a performance and maintenance thing for them. That's what they chose. And as being an awesome director, as already pointed out, I've trusted their opinion and said, okay, let's go with that. It's going to work, right? So yeah. But I'm really excited to hear about React coming back. It's reborn. I was at your talk, so it's really, really great to hear. I'm really excited what you guys are going to do. It's going to be awesome. Over here.
Say a few more words on test. You use CT, you use proper. What do you use for your testing?
For the testing in Erlang, none of those.
Okay.
What's some of the other testing frameworks that are out there? No. Which one? No, it's not that one. Can't remember.
You mostly do performance testing, you said, right?
Mostly, yeah. I mean, we had testing. We had tests and ran all the tests, but I can't remember what that was run through.
Plain old test, right?
Yeah, it's just unit tests, right? And then we would do performance testing for the other side of it for that. So, wish I could answer that question. Okay, sorry.
And do you have a culture of write? Do your devs have to write unit tests before they can write code?
We don't have a culture. That's TDD, if what you're asking. No, we don't have a TDD culture. But we do have, any system that's written has to go through our pipeline and has to have X amount of coverage. We don't say you got to have 95% or 100. That would be ridiculous. You can't test every single line of everything. But you do have to have coverage. And then it goes through the pipeline of security checks and all kinds of stuff that goes through the CI builds and CD builds and stuff like that. But yeah. Okay, a lot of questions. So I don't want to keep hogging up time. People got to come in. The next speaker. I'll be at the lounge. You guys want to hang out, and we can talk there if you guys want. Okay. Really appreciate you guys coming. I really do. Thanks.